see this picture to understand how this set associative mapping works. Okay, so this is your, let's say, tag field, and this is set offset, this is your word offset. Okay, now this is completely your main memory address. First of all, what happens is, this is your cache. Okay, especially in this cache there are a lot of blocks, but this is only a particular set. Okay, similarly you have lot of such sets. I am not showing all the sets, I am showing only one particular set. Now first of all, this set offset is going to decide the particular set which we are looking for. Understand? So based on the set offset pattern, one of the set will be selected. Okay, so here currently this, let's say this set is selected. Which set? This one, which is shown in this rectangular box. Okay, now in this set we have 4 blocks because it is 4-way set associative mapping, let's say. Okay, just assumption. Since it is 4-way set associative mapping, each set contains 4 blocks. Sir, why this set is selected? Because of this pattern, right? Once the proper set is selected, then immediately this tag bits will be compared against each tag field. Assume that each block has a tag field. I am showing here, okay, for convenience. Generally we write here tag field, right? But here I am showing. So here every block has tag, right? So there are 4 tag fields. We have to compare them parallelly. So that's why this tag bits will be compared against this main memory's tag field. So one comparator here, another comparator here, third, fourth. In that way there will be 4 comparators which works parallelly. So they are all, the results will be connected to OR gate. Now example, really you are looking for a data which is this block, let's say. Then what happens? This tag definitely matches with this tag. At that time this comparator's result will become 1. Since we keep data only once, we don't repeat the data, so that all other blocks will become zeros. That means all these tag, not here, all these results of comparisons will become zeros. Understand? So finally anyhow this R's result will become 1. If no block is matching, then what happens? This tag, this tag, this tag, this tag, every tag will no tag will match, so that all the results will become zeros. That is about whether finding the data or not. That means hit or miss will be decided by this OR gate. Now second thing, once you hit the data, how to fetch it, right? Example, let's say this is your data. Then but I want to only find out the right word, correct? So that's why remaining bits will be used to find out the right word. But so far, sir, how to select a block? We don't have any mechanism so far to find out the correct block, right? So this OR gate just simply says that yes, data is available, but where? That's why we use multiplexer sometimes. Okay, how multiplexer will be used? You see, let's say every block's data part is, let's say, connected like this to a multiplexer, 4x1 multiplexer. What are the inputs for this 4x1 multiplexer? All these blocks. Okay, one of them to be selected, that will be the right block. But who will decide that? These comparator results. Okay, so all the comparator results are again connected to these control lines. Example, let's say the first block is the right block, our data block, then this comparator's result will become 1, then this will become like this 1 0 0 0. We should design this 4x1 multiplexer such a way that whenever this 1 0 0 0 are the control lines, then the first block should be enabled. If this is 0 1 0 0, then second block should be enabled. In that way the right block should be enabled. That should come out. Once we get the right block, okay, then using the word offset we will find out the right word, and using byte offset we can find out the right byte if you want. Understand? So this is the way your set associative mapping works. Understand? But you can see the costliness here. Lot of comparator circuits. Number of comparator circuits equal to 1 2 3 4. Number of bits in tag comparator, that means the size of the tag comparator. Okay, sometimes they ask that question also. Size of the tag comparator is nothing but what size tag fields it compares. Understand? So that depends on the tag field of the main memory address. So if you find out the tag field size, we can find out the comparator size. It's not a big deal. Understand? So this is a complete details about this set associative mapping. Okay.